So we'll be continuing with mesh analysis. So the question is, find current in 2 ohm resistor. So this is given as 6 ampere. This is 12 ohms. This is 36 volts. Then this is 6 ohm. This is 3 ohm. This is 2 ohm. This is 9 volt. This is I1, I2, I3. This is given in the question. So I1 will be 6 ampere. I1 is going upwards. 6 ampere is also upwards. Next I will say apply KVL to mesh 2. When I apply KVL to mesh 2, starting from this point, negative to positive, plus 36 minus 12, I2 minus I1 because I am applying it to I2, minus 6 I2 minus I3 equal to 0. So 36 minus 12 I2 plus 12 I1 minus 6 I2 plus 6 I3 equal to 0. So this is 12 I1 minus 18 I2 plus 6 I3 equal to minus 36, equation number 1. So this is not equation number 1. I1 is given as 6 ampere. So 12 into 6 minus 18 I2 plus 6 I3 equal to minus 36. So (108). So minus 18 I2 plus 6 I3 equal to minus 108. This is equation number 1. Next I say apply KVL to mesh 3. When I apply KVL to mesh 3, I get minus 6 I3 minus I2 minus 3 I3 minus 2 I3 minus 9 equal to 0. Minus 6 I3 plus 6 I2 minus 3 I3 minus 2 I3 minus 9 equal to 0. 6 I2 minus 11 I3 equal to 9. This is equation number 2. So I2 equal to I3 equal to two variables. So I'll say minus 18 plus 6 minus 108 6 minus 11 9. So 7 amperes and I3 is 3 amperes. So current through 2 ohms is I3. So I say current through 2 ohms is I3, which is 3 amperes. Next question. Find current in 10 ohm resistor. Find current in 10 ohm resistor. So this is 6 ohms. This is 5 volts. 4 ohms. This is 2 volts. 10 ohm. 15 ohm. 5 ohm. This is 20 volt. So current in 10 ohm resistor. That means this. So assume the direction of current as clockwise. Name the current as I1, I2, I3 and apply mesh analysis. So apply KVL to mesh number 1. When I apply KVL to mesh 1, starting from this point, I get negative to positive plus 5 voltage drop. So minus 6 I1 minus 4 I1 minus I2, because I am applying KVL to mesh number 1. So current I1 will be greater than I2. 5 minus 6 I1 minus 4 I1 plus 4 I2 equal to 0. This will become minus 10 I1 plus 4 I2 equal to minus 5. Equation number 1. Apply KVL to mesh number 2. When I apply KVL to mesh number 2, starting from this point, minus 4 I2 minus I1, negative to positive plus 2, minus 10 I2 minus 15 I2 minus I3. So minus 4 I2 plus 4 I1 plus 2 minus 10 I2 minus 15 I2 plus 15 I3. So 4 I1, then I2 will be so collect the I2 terms 4, 10 and 15. That is 29 I2 plus 15 I3 equal to minus 2. Equation number 2. Then I will say apply KVL to mesh 3. When I apply KVL to mesh 3, starting from this point, then I get minus 15, applying it to mesh 3. So current I3 is greater, so I3 minus I2 minus 5 I3 positive to negative minus 20 equal to 0. Minus 15 I3 plus 15 I2 minus 5 I3 minus 20 equal to 0. So 0 I1 plus 15 I2 minus 20 I3 equal to 20. Equation number 3. So minus 10 I1 plus 4 I2 plus 0 I3 equal to minus 5. Equation number 1. So 1, 2 and 3. 3 equations, 3 unknowns, I1, I2 and I3. So find the value of I1, I2 and I3. So let's see. Zero point 2275 ampere minus 0.6811 ampere and minus 1.5108 ampere. So current through 10 ohms is asked. So current to 10 ohms is I2. I2 is negative. So assumption is wrong. We had assumed that current I2 is moving rightward through the 2 ohm. But answer is negative. So current is not moving in the right direction. Current is moving in the left direction. So we write here current through 10 ohm resistor is I2, which is 0.6811 ampere, but in the left direction. We had assumed it to be in the right direction, but current is not flowing in the right direction, it is flowing in the left direction. Find current in 20 ohm resistor. So first assume the direction of current, mark it as in the clockwise I1, I2 and I3. Then we write apply KVL, to mesh number 1. When I apply KVL to mesh 1, starting from this point, negative to positive, plus 20 minus 15 I1 minus 20, we are applying it to mesh 1, so I1 current will be greater, so we say I1 minus I2 equal to minus 10, I1 is greater than I3, so I1 minus I3 equal to 0. So this is 20 minus 15, I1 minus 20, I1 plus 20, I2 minus 10, I1 plus 10, I3 equal to 0. So collect the I1 terms. So I get here minus 45 I1 plus 20 I2 plus 10 I3 equal to minus 20. Equation number 1. Apply KVL to mesh 2. Apply KVL to mesh 2. When I apply KVL to mesh 2, starting from this end, minus 20 I2 minus I1 minus 60 minus 15 I2 minus 5 I2 minus I3 equal to 0. Minus 20 I2 plus 20 I1 minus 60 minus 15 I2 minus 5 I2 plus 5 I3 equal to 0. 20 I1 minus 40 I2 plus 5 I3 equal to 60. Equation number 2. Apply KVL to mesh number 3. So minus 10 I3 minus I1 minus 5 I3 minus I2 minus 5 I3 plus 40 equal to 0. Minus 10 I3 plus 10 I1 minus 5 I3 plus 5 I2 minus 5 I3 equal to minus 40. 10 I1 minus 5 plus 5 I2 minus 20 I3 equal to minus 40. Equation number 3. I1 equal to I2 equal to I3 equal to I1 is 0.4072 amperes. I2 is minus 1.0538 amperes. 1 point current through 20 ohms is I2 and I1 both is there in between. So we will say from I1 and I2 the one which is greater will be subtracted from one which is smaller. So I1 is greater, so I say I1 minus I2 in the direction of the larger current. So in the direction of I1 through 20 ohm is going downwards, so the current direction will be downwards. So I'll say I1 minus I2. I1 is 0.4072 minus of minus 1.0538 is nothing but 1.461 amperes in the direction of I1. So it will be I2 minus I1 in the direction of the larger current, the larger one. So first we will compare that if it is between two mesh, then we will consider the current of individual mesh, and from the current of individual mesh we will find out which is the larger current, which is the greater current, and accordingly we will subtract the larger value from the smaller value and give the direction of the larger value. So I1 minus I2 in the direction of I1, it is I1 minus I2 in the direction of I1. Next question is, find current supplied by 100-volt battery. Find the current supplied by 100-volt battery. So this is 100-volt battery. This is 10 ohms. This is 10 ohms. This is 10 ohms. This is 10 ohms. This is 50 volts. This is 10 ohms. So first assume the direction of current and name the current as I1, I2, I3. For simplicity, assume in the clockwise direction. Apply KVL to mesh 1. To mesh 1. When I apply KVL to mesh 1, negative to positive, plus 100 minus 10 I1 minus 10 I1 minus I3 minus 10 I1 minus I2 equal to 0. So for this, I1 is greater because we are applying KVL on mesh 1. So current I1 is greater than I2, and for this again we are applying it on mesh 1, so I1 is greater than I3, so I1 minus I3. 100 minus 10 I1 minus 10 I1 plus 10 I3 minus 10 I1 plus 10 I2 equal to 0. So collect the I1 terms. Minus 30 I1 plus 10 I2 plus 10 I3 equal to minus 100, equation number 1. Next I'll say apply KVL to mesh 2. When I apply KVL to mesh 2, starting from this point, minus 10. Now I am applying it to mesh 2, so I2 minus I1 minus 10 I2 minus I3, positive to negative, minus 50 equal to 0. So minus 10 I2 plus 10 I1 minus 10 I2 plus 10 I3 minus 50 equal to 0. 10 I1 minus 20 I2 plus 10 I3 equal to 50. Equation number 2. Next I'll say apply KVL to mesh 3. When I apply KVL to mesh 3, I get minus 10. Applying it to mesh 3, so I3 current will be greater than I1 minus 10 I3 minus 10 I3 will be greater than I2 equal to 0. So minus 10 I3 plus 10 I1 minus 10 I3 minus 10 I3 plus 10 I1. Sorry, I2. So 10 I1 plus 10 I2 minus 30 I3 equal to 0. So I1 equal to 3.75 amperes, I2 equal to 0 amperes, and I3 is 1.25 amperes. Current through 100 volt is I1. So my final conclusion will be current through 100 volt battery is I1, which is equal to 3.75 amperes.